If this is the first video of mine that you are watching and you don't have very much experience in Python, I would highly recommend that you go back and watch the one right before this, where I will walk you through how to access the files for this project and also how to get your environment set up in Google Colab. If you have absolutely no experience with Google Colab, I would also recommend my introductory video just that's specifically about Google Colab because it'll walk over some of the basic functionality and get you up to speed so you can follow along with this one. If you do have some experience in Python and Google Colab and you just wanted to walk through the analysis that I did, then I hope you enjoyed this video and I hope it's worthwhile, and we'll be following this up with more videos in the future. Thanks. So at some points in this video, I'll be showing the Python script in Google Colab kind of next to Excel to show you the differences in how I did the data manipulation in both programs. And I hope that that will be helpful, especially for those of y'all who are still really comfortable with Excel or more comfortable with Excel and trying to learn how to do some of that basic operations in Python for data manipulation. I did not have all this figured out on the first go around, so the video is smooth, but it's only because I edited it significantly. And, I'll mention in the video a couple of points where I realized later on in my script that I had done something incorrectly before I had to go back and try new strategies. And that's totally normal. I think that's a normal part of any code project, programming project, especially any part of a machine learning or data science project. So don't feel bad if that happens to you. It's very rare for people to get everything on the first try. That's why we have Stack Overflow and debugging and friends for you to call and ask for help. So those two are done. My data set is loaded up. I've got my packages imported. I'm ready to go in terms of analysis and stuff. Okay, so for this project, we really wanted to know what we wanted to do was track changes in gender discrimination laws in the workplace over time. So we had this data set from the World Bank that had these 8 features tracked from 1970 to 2021. We wanted to know when the values changed. So the value is a binary value, either 0 or 1. You can see up here. So like, for example, this feature is whether or not it's against the law to fire pregnant women. So 1 means that country does have a law in place that prevents you from firing a pregnant woman. And 0 means no, the country does not have a law in place that prevents pregnant women from being fired. So we wanted to know when that value was changing so that we could also compare that to wage data to see if changes in these laws had any impact on earnings of women in those same countries for the next few years after the law was implemented or repealed. So in order to do that, I needed to generate some additional columns so I could calculate the changes from year to year in the features. So we needed to generate additional columns to calculate the changes from year to year in each of these features. So what that looked like in Excel when I did it was very simple. I just did like insert a new column, change of this feature. And we can't do it for 1970 because we didn't have 1969 data. So we started at 1971 and it was like equals this cell minus this cell, right? Super easy. Copy and paste values only. So we needed to create one for each feature, right? So 8 new columns. This is what I did initially. So that was the one I called my friend Jason, who's really good at programming. And I was like, Bud, I need you to tell me how to do this. He's like, I think you can use the diff function. And he was right. So the way that looks in Python is basically if you want to create a new column in a data frame with pandas, all you have to do is tell it the name of the column. We're using the data frame variable here, WBD, and I want to create new columns that calculate the change in the law status for each of the 8 laws. So 8 new columns here. I'm telling it here that it's going to use the .diff function, which I pulled up in the pandas documentation, and it shows that the default function, so if you don't assign any parameters for this, if you just call the default function, it will take the difference over rows or columns. So the default is rows, And it basically calculates the difference of an element compared with the other element in the previous row. So that's exactly what my little function here is doing. In the code, we, like I said, eight new columns. You're assigning them with the in single quotation marks, and that's why the color changes. And then you just tell it what column you want it to calculate the difference in each row on, and you name that column here, and then you put .diff and then just open and close parentheses. That's how you do just the default function. So I had to do that 8 times for each of the new ones. So then I like to do another check. I'm going to print the first 6 rows of the data frame. So that's the header function, or head to see what it looks like. Okay. So now you can see we have this, our country name, country code, year. And then we have our original 8 features, the legal status. And then we have our new 8 features that calculated the change in the status. So you'll notice the first row is 1970, and it gave us NaN values across the top because it was not able to calculate anything from the previous year because we don't have 1969. The next thing I wanted to do is get rid of those 1970 observations because it doesn't give us any value. And so basically what I did here is reassign to the same variable name. So overwrite the copy of the data frame that I already have. And then I'm telling it that I want it to use the exact same data frame, but I want it to filter out the year column, every value that does not equal 1970. So I'm creating a new data frame, but I'm reassigning it, overwriting the old version, and only keeping the records that have not a 1970 in the year column. So in Python, this means does not equal. If you wanted to use equal, like if you want to say, if I wanted to filter out everything that equaled 1970, you use a double equal sign. If you use a single equal sign, you're just assigning a variable, or it thinks you're trying to assign a variable. So we wanted everything that does not include 1970. And then I wanted to check the header again to make sure that it was gone. So now it starts with 1971. And in Excel, you would have had to you could have filtered, you had to go through and copy and paste all of these to values only so the formulas didn't get messed up. And then you would have had to filter out all of the 1970s and clear the contents, or delete all the rows or something like that if you wanted to do that in Excel. Since we were interested in the change features, I wanted to create a new data frame without the original just binary legal features. And then I realized later on that I also needed a copy of the data frame with just the country code, the country name, and the year. I figured that out later when I tried to rejoin the data frame that I had conducted analysis on with the country code and country name and stuff. I wasn't able to. It was just kind of a mess. And so I figured out this is what I needed to do. So, but I didn't know this initially. So I made 2 versions of it. The first one, I dropped every column except for country name, country code, year, and country year. So the country year will be our unique identifier for each row. So that's what the WB3 column is, or data frame is. And then the WB2 data frame is the one that I'm going to conduct the analysis on to figure out where the changes happened. So now we have this data frame that has all of these columns, but we don't know exactly where in this 9,828 rows the changes actually took place. So that was the next step that we needed to do. In Python, to drop columns is actually really simple. You just give it the data frame .drop. This is a pandas function, and then open parentheses, columns equal, and then open square bracket. So you can list any number of columns here that you want to remove from your data frame, just separated by commas. But just keep track of your single quotation marks and stuff, because if, for example, I delete that comma, things will get funky. It won't work. So you just got to keep track of your commas and your quotation marks and make sure everything looks right. So I ran that. Now I see 2 new things popped up in my variables here. So this one has 9,639 rows because we removed all of the 1970s. And then the WB3 has my 4 identifier columns. And then the WB2 has the 9 columns. It has just the country year as the unique identifier. and the 8 change columns that we made. So another quick check. Just kind of look at them, make sure they have the right ones. All right, so this WB2 is what we're going to use to find where the exact year in each country that a law changed. So this is what it looks like now. We just have the country year as our index column, basically, and then we have the 8 change features that we made. So because of the summer class I took, I knew that one approach to do something like this is to start with an empty new data frame, and then basically you can run a loop that will add a row to the data frame based on whatever parameters you give it. So you can tell the loop to scan through something, and then when it finds the thing of interest, put it in a new data frame, like copy that whole row and just move it over to the new data frame. So that's the approach I wanted to take because it was something that I learned over the summer. So to create an empty data frame, all you have to do is use pd.dataframe and just leave it as the basic function. You don't have to assign any parameters. There is functionality on here where you can assign different parameters. You can tell it the number of rows and columns you want it to have. You can fill it with zeros. You can fill it with nans if you want to. There's a lot of different things that you can do, and the documentation walks through that really well. New data frame, I called change. Here it is, 0, 0, 0 columns, 0 rows. And then I had to get help on this loop. So Jason had to help me with this as well. I knew what I wanted it to do, but I didn't know the exact functions that I needed to tell it. You know what I mean? I was like, I know exactly what I need to do. And in Excel, it would have been something like, filtering out all of the zeros. I think what I did initially was something like find and replace, and removed all the zeros and replaced it with just empty cell. Yeah, so I had done this like find and replace, and I replaced all the negative ones with repealed. And then I replaced the ones with implemented. And then 0 with nothing. So then in Excel, you could just filter out and say, okay, now I can know exactly when this law was implemented in what country and what year. So the way that looks in Python is that using this simple for loop. So this first line is for index in range of length of WB2. So index is this 1, 2, 3, 4, 5 column that Pandas has assigned to this data frame. So what this first statement is saying is for every single row and every single column, it's going to iterate over every single cell. I want it to find if that value does not equal 0, basically. And there's a couple of ways you could have done this. Looking back, I probably could have done this a little differently, but this next line was Jason's suggestion, and he's much more of a Python expert than I am, and it worked. So iLoc will find any integer position. You can tell it exactly where you want it to look in a data frame. And it can be used with a Boolean array, which is what Boolean is, like 0 and 1. And there are other versions of this we looked at when I was talking with him. So there's .loc and there's .iat, and these are all different based on the data types and stuff and the way that you want it to scan. But iLoc is the one that we ended up using here. And so we're telling it, I want it to say, so for every cell in the data frame, if it finds a cell in the whole index past the first column, this is column 0, this is column 1. So starting in column 1, I want it to let me know if it finds anything that is not a 0. So this as type, you can tell it what kind of data you are looking for. So Boolean is what he suggested, and the default is true. So in Python and most programming, Boolean logic, 0 is false and 1 is true. So the default on the Boolean setting is true. So it's going to look for anything where there's a 1 or a -1, basically. So it'll skip over all the zeros. And whenever it finds something that's not a 0 in one of these cells, it's going to copy that row and append this empty data frame with that row information. So that's the append function from pandas. So there's a lot of parameters you can use here as well, but we can use the basic function for this purpose, basically. So we're telling it for every cell, scan every cell in every column, starting with, or the second column. If it finds an integer that is not a 0, it is going to copy that information and append it or paste it into this empty data frame. So let's run that. And you can see it iterating over the numbers of the cells and where it finds them. And you can see over here that it's creating this data frame. So it's done. So now we have this new data frame that has the 472 rows or 471 unique observations where laws changed. So let's take a look. We've got it here. So we know the first one was in Afghanistan in 1988. And it was when they implemented a law that said you can't fire pregnant women anymore. So basically, because of the way the diff function and this function calculated things, if there is a 1 somewhere, that means that a law was implemented because it would have been calculating 1 minus 0. And then if there's a -1, that means that a law was repealed because it would have been calculating a 0 minus 1. So that's what we have here. So here's a -1, for example. That's in 1999. They repealed the same law that they passed in 1988. This is the manipulation that I did where I did find and replace and added all of the categorical like language instead of just the 1s and 0s. So what I wanted to do first was get rid of the 0 values. And I made a copy of this data frame just in case I messed something up so that I wouldn't have to go back and redo all of these steps. So first I made a copy called changes. And then that's the one that I manipulated with the categorical features. I also thought we might want to retain this data frame with the numerical values in case we wanted to perform different types of analysis. So first I wanted to get rid of the 0s. So here I'm using a pandas function replace. And then basically what you're going to tell it, there's several parameters that you can give. So the parameter for to replace, it can be a string, it can be a numeric value, an integer, a series, a dictionary, or a float value. What we were looking for is integer. So we're telling it, I want it to find all of the 0s and then replace it with what? Just nothing. So I'm telling it an empty string, basically. So you tell it what you want it to find to replace, and then you tell it the value that you want in that cell instead. So that'll get rid of all the 0s. And then to get rid of the -1s and the 1s, basically it has to iterate over each column. I'm rewriting over the column and replacing the -1 with repealed that law and the 1 with implemented that law. So I had to copy and paste this for each of the 8 columns. And it's basically the way that this is assigning it is going to overwrite each column with these values. All right, so now I have this new data frame. Let's look at it. There we go. So now we see Afghanistan 1988 implemented the pregnant worker one, and then in 1999 repealed the pregnant worker one instead of these just 0s and 1s. So then the next thing I wanted to do is consolidate all of the columns. I wanted to have just the country year and one column that indicated what the change was. And so you would end up with multiple countries and years potentially in the observations, but then only one feature that says what actually happened to summarize it or to be able to like pivot it. In Excel, this took me a long time. So I actually did this manually in Excel first. And I did this, I put like implemented EQRM and I did find and replace on everything. And then I just started deleting columns and like dragging cells over. So I was like insert. So Algeria had 2 changes. I would insert rows and then I'd be like copy and paste, move this over here. Like it took forever. It was a long time. So basically the way you can do that in Python is called melt. So this is one of those reshaping functions.
There's a lot of tutorials online for melt and pivot and stuff that are very helpful. I think I looked at probably 4 or 5 of them to figure out exactly what I needed to do because none of the examples really were what I was looking for. And I didn't understand a lot of these parameters that were in the documentation. So I ended up looking at several tutorials to figure this out. The documentation is helpful, but sometimes the tutorials are easier to understand. So basically what I needed to do, you can prescribe it. This is when I figured out that I needed a data frame with only one independent variable. So one feature that was the unique identifier and not all of the country and year and country code and country year. This is when this melt function is when I realized that I needed those 2 different data frames. So basically you can ascribe it one, they call it the ID variable. So this is the one that's not going to change, and this is the one that's going to remain as your first column. And then you can, what it's going to do. So here's the example from the tutorial. So it has this data frame, and what they're doing in this example is they want to reshape this data to where, so do you see what's happening? And here we have the names. So John is in the master's course and he's 27 years old. In this example, they're creating a new column with all the courses, or a new column that has just each cell says course, and then it inserted itself between that and the value, which is whether or not they were masters or graduate. And then it also would put their age here. So in this example, the ID variable is the name, and then it melted all of the other data underneath it. So this is the wide to long version. So in the code, the country year was the ID variable. And then it's basically what it did was took all of this information that was in the data set, all of this, and melted it down into one column. And you can give it the name of the column that you want to call it. And so I called it just change. This is a new variable name I'm making. So the melted version of this data frame is changes.melt, and then the ID variable is the country year, and I want the value name to be called change. And then we're going to print the header of it and see what it looks like. So yeah, that's what we got. So basically, we have the country year, and then it gave a variable column that came from the column name here. So basically, it's saying in this column for Albania in 2016, there's a value that said implemented EQRM. But because of the way I did the replacement of the text with the categorical language, we don't actually need this variable column. So the next step was just to delete that. Because now we know the change was that they implemented. So if you had done it differently, like if you had just said, if you didn't have these codes in here, then this would be helpful and you might have to do some additional manipulation. So like I said, I had to go back and it was an iterative process of figuring out exactly what I needed the data to be in, the shape it should be in to begin with. So there's the melted version. I want to delete this variable column because I don't need that because the change actually says what the change was. So I'm going to drop it again. So change underscore melt is the name of the data frame, dot drop. And then the column, just the variable column. So now let's look at it again. So now we have just the country year and what happened. So then after we did the way that it melted, so it basically created up rows for every single column here. So there's a row for Afghanistan 1988 for this, Afghanistan 1988 for that, Afghanistan 1988 for that. And so you can see there's no values here. The only change that happened in 1988 in Afghanistan was that they implemented the pregnant worker law. So that's why there's nothing here. They didn't change this law. These countries in these years didn't change this law, but there might be changes further down. So this is just the header. It's the first couple of rows. Basically, the next thing I had to do, and it took me a while to figure this out, I knew that I wanted it to filter out all of the empty, I didn't want to see these, right? There's nothing in the change column, so I don't want those in the final product. And I tried several different versions of this, and this is what I figured out to get it to work. So basically what I did is I created a series, like a dictionary kind of, that had all of the values that I was interested in, and I copied them from up here. So every single one implemented or repealed for every single law of the 8 laws. So there should be like 16 names in this series. And then after you create the series, you're able to pass it as a parameter for the .loc feature in Pandas. So I wanted to create this final table that would sort through the change melt data frame and locate any cell in the column called change that had a value that is in my series. So now I can pass that series here as a parameter to this .is in, and it's going to search for any cell that has one of these values in it and create this data frame with those rows. So that's what it looks like. Then I wanted to merge back the original data that had the country name, country code, and year. So we could do like a pivot table, basically, is what I had done in Excel. So the thing that is in here, this is just a pivot table, right, from Excel. But in order to get that for like the countries and the specific laws, I needed to not only have this unique identifier with the country year, right? Because most of the changes just happened in one country year. So I wanted to bring back in the appropriate year and country name for each of these rows. This is when I figured out I needed a version that only had those 4 features in it, because when I first tried to merge it back to the full data set, I got everything. And I was like, it had all the original features in it and everything. I was like, I don't want all that. I just wanted this information, right? So that's why I created that data frame here that had just that information. So then I'm able to use that to merge back to this new table. So I created this final two and then merged it. So final.merge with WB3, which is the data set that only had the 4 columns of country name, year, country code, and the country year. And I'm telling it that the merge identifier should be the country year field. So that's what I want it to find. It's going to look for, this is basically a VLOOKUP. So this is what I would have done in Excel. I would have done a VLOOKUP and say VLOOKUP in the country year column, and then have it return the country name, the year, and the country code. So this is, and with Python, you can do it as merge. So let's see. So now we have the country year, the change, and then back in the country name, the country code, and the year. So now we can use this table to summarize things by year, by country, or by the change. So if we want to know exactly how many of these there are, or exactly how many laws Albania changed, or how many laws were changed in 2016, that's why we needed this version of the data. So then I wanted to basically create a pivot table in, in Python. So in Excel, very easy to do, insert pivot table, done. In Python, it's a little trickier. So I created this summary table of just the years. So I wanted to see in what years the different changes were happening. So I'm creating a new data frame called years. I'm having it pull the data from this final 2 table that we made. I want it to search for the year column and then give us back the number, the sum of how many there are for that year. So like the count. So that's the value counts pandas thing. And then I also wanted to rename that column as the count of changes and create I named the index column as the year. So let's see how this looks. And then you can just type the data frame name here to just print the whole data frame. So this is what it ended up with: year and count of changes, and it automatically sorted it in descending order. So in 2005 was the most number of laws that were changed. So now this table is what we can use for like visualization, like simple visualization, line plot, bar plot stuff. And then I did the same thing with the countries. So countries, new data frame. We want it to search the country name and then give us how many counts of that country there were. And then call it the count of changes again. And the index is going to be the country. So this is what it looks like. Country. So Togo and South Africa had the most number of changes in these laws. They both had 8.
All right, you guys did it. I hope that you guys were able to follow along and learn with me. I have learned so much through this process. And again, I'm so appreciative of my friends and lab mates and teammates that helped me when I needed help. I would love to be a resource for those of you who are learning along with me. Feel free to hit me up on LinkedIn, shoot me an email or something. I'll put my email on the final slide. So we will be following this up with some more videos, but I've got a lot of stuff happening in the next few weeks, so I'm not exactly sure when I'll be able to get to them. But the next video in this series will be the final video for the WID Datathon. And in that one, we will go over the other notebook that my teammate put together where she matched up data from the International Labor Organization to try to track any changes in the wage data for women in the countries where the gender discrimination laws were changing. So that was the final step in our analysis for the Datathon. Thank you all so much for watching. I really appreciate the support. I hope this helps, and I look forward to sharing more knowledge and learning from you all in the future.